Uh, just let me know what do you know about Hadoop.
Hadoop is a distributed file system.
Hmm.
Um, it works on master-slave architecture.
Hmm. Fine. Okay. Let's go to it.
Yeah,
Hadoop. What I said that's correct, but it doesn't not only stores the data but also provides processing also. Okay. It is can be
yeah,
used for storage and processing. Storage of what? Storage of what? What up? So generally that will be data only. We call it as data storage and
yeah,
data processing. Okay. And what the component that for storage that is called as HDFS. It is a file system, Hadoop distributed file system, and this processing this has been created as yarn. I think you might have heard about this yarn. Okay, is
yeah.
the file system and yarn is a processing system. Okay, and
Hmm.
finally overall this is a project of Java actually. That means they have used Java language for developing the entire framework. This Hadoop and then developed చేసింది to only by using Java language. Okay, so obviously HDFS and yarn also will be Java projects only. Now this is HDFS is a file system, is a file system for storage purpose, that is Hadoop distributed file system, and the full form of yarn is yet another resource negotiator. Another resource negotiator. Okay, this is the full form of yarn. Okay,
Okay.
now what is the architecture followed by the Hadoop is, as you said, that is master slave architecture. Okay, so obviously even HDFS is going to follow the same architecture, that is master slave architecture, and even yarn is going to use the same architecture, that is master slave architecture. Okay, master slave and everything is master slave. And actually how where it is going to run, how we have to install Hadoop, on what operating system this Hadoop is going to work. First we need to have that kind, basic understanding of that, then we can explore more on that. Is this part clear whatever I have written here? Hadoop
Yeah, yeah.
storage
That's okay.
processing, fine. Let's see this now. So where do you install Hadoop and how do you use Hadoop? How do you use Hadoop? Where to use it actually? On what operating system we need to install? How many machines are required? And what has to be the memory required? All these come into picture. So obviously we are going with Hadoop for dealing with the huge amount of data. So obviously it needs more than one machine. Okay. First thing is
Yeah.
it is used for storage and processing of data that just now we have seen here. How much amount of data? How much amount? What amount of data can be stored and processed by Hadoop? Okay,
A huge amount of data.
huge amount of data. They did not specify that this is the size, this is the, they did not set any boundaries for the amount of data. So we can say that unlimited. Simply, we can say that unlimited. But generally, in the data in terabytes and petabytes will be considered as huge amount of data. Okay, and
Yeah.
what type of data? What format of data? Well, because data is in different formats. If you use Facebook or YouTube, if you use Facebook or WhatsApp, there we use text, there we use audio, there we use video. Okay, and XML formats, XML files, JSON files, text files. We have different PDF files, we have different types of files are there. Okay, so this HDFS or Hadoop can store and process any format of data, any format.
Hmm.
So the formats of data have been divided into three types: unstructured, semi-structured, and you can guess about one more. What is it?
Structured.
Structured, unstructured, semi-structured, and structured. Three formats of data it can store. Okay, so any
Yeah.
format, any amount, any size, and any format. Okay, and one more we have that is called as, suppose if the data is getting generated, 1 petabyte of data is getting generated in just 1 minute. Let's assume like that, in just 1 minute. Suppose
Hmm.
if we try to load 1 GB of data into our machine, let us say we are trying to copy 1 GB of data from external hard disk into our machine. How much time it will take? How much time?
Sorry, come again.
Uh, if you're trying to what you call as copy some 1 GB of data from external hard disk into our laptop or desktop, how much time it may take for copying the data?
Hardly 5 minutes.
5 minutes like that, right? So let's that's only 1 GB of data. Suppose if we talk about
Hmm.
petabyte of data, how much time it will take to load the data into HDFS or to process this petabyte of data? How much time it has to take? Okay, that should not be too long. Okay, that should not be too long. Whatever maybe the ఎంత amount of data వచ్చినా సరే, whatever the amount of data, that time for processing and storage of data has to be minimum, the maximum minimum. Okay,
Yeah.
to the extent possible, ఏ possible అంత possible minimum అయి ఉండాలి, so that performance can increase. So whatever may be the amount of data, if the petabyte of data is getting generated 1 minute or 1 hour or 1 day, doesn't matter. This Hadoop has the capability to accept any amount of data with whatever with the velocity it has been generated. Okay,
Yeah.
see this, how many messages and how many images, how many videos are going to be uploaded to YouTube and this WhatsApp every day or for every minute. Actually it will
Very.
be very very numerous, ఒకటే రెండు అని చెప్పలేము. Some lakhs of videos will get uploaded, will get uploaded per minute. In per hour they go to some lakhs and crores also. That is how the number of the users are using those applications. So the amount of data generated will be very very fast actually. చాలా తొందరగా జనరేట్ అవుతుంది. It is not taking
Yeah.
months and years to generate petabyte. It's just simply taking hours to generate petabytes of data. So this storage system and processing system must be able to process any amount of data. It has to accept. Suppose if you try to load 1 petabyte of data, it should not take 1 day or 2 days or 3 days. It has to complete in hours. Or if possible, still it must be able to do that in minutes only. So the third parameter would be velocity. With whatever the speed the data gets generated, it has to accept it. It has to work on that. So the first one is talks about volume here. That is what term with the volume of data. Second things comes about variety. That is any format of data or any variety of data. And third parameter talks about velocity. Velocity. So three parameters: volume, variety, and velocity. And one more parameter also being included, that is called as veracity. Veracity. This is nothing but accuracy of the data. Accuracy. So we are loading some data from one machine to another machine or huge cluster. Do you think security is provided to the data? Is the data gets delivered properly or not? So even that will be verified. That is even acknowledged by the Hadoop distributed file system. So when it gives that flex feature also, so that feature is called as veracity. Volume, variety, velocity, and veracity. Any amount of data, any variety of data, whatever with the speed, with any speed and with accuracy. So these are the four features, okay, of Hadoop distributed file system. It can handle any amount, any variety, any speed, and with accuracy. So ఇవన్నీ ever who is going to provide all this is Hadoop is going to provide. This is the reason most all the organizations are using this Hadoop for storage and processing. That's it, very simple.
Hmm.
Okay, right.
Yeah.
Now coming to this next point is, now, so obviously we are going to have, let us discuss about the architecture now. What is that master slave architecture, how it is going to be? Just let us have some overview only. Okay, we shall get into details later. Let us just have the
Hmm.
overview in this session. Okay, suppose I ask you a question actually. Suppose if you have a laptop, let's say the hard disk of the laptop is 1 terabyte. Let's assume like that.
Yeah.
So that hard disk is totally filled up. You have some data to copy into it. So what do you do?
I need to delete some of the unused data.
No, data should not be deleted.
I have to increase my storage capacity.
Exactly right. Okay. Instead of if you want to increase it, the disk must be again replaced, right? The disk must be replaced,
Yes,
and at the same time, what has to happen? What are the data that we have in 1 TB disk that must be moved to the next disk, the new disk? So idanతా
right.
జరుగుతుంది. Do you think is there any other way of without copying the data? Is there any other way of handling that extra data? Another solution instead of replacing the disk. Is there any other way?
No.
Yes. Don't we have external hard disks?
Yes.
With external hard disk, okay, we can copy the data into the disk. So whenever we want, we can plug in and we can use the data. That acts as some
Right.
second hard disk, like that, external hard disk. Okay. So I say that here, in between these two, what are we trying to do? Actually, we are trying to increase the memory, isn't it? We are trying to
Hmm.
increase the storage capacity. So if we're trying to increase or decrease something, we have a particular term for it. What is that? Increasing something or decreasing something. It can be like this also. We have a term that is called as
Scale.
scaling. Okay. If we're trying to increase something, generally we call it as what? Scale up unto term.
Hmm.
Scale up. And if it decrease, we call it scale down unto a general term. So as we're trying to increase the storage capacity, we are trying to scale up the memory. We're trying to increase the memory scale. That means ఏ స్కేల్లో ఉండాలి అంటే ఎంత సైజ్ డేటా స్టోర్ చేసుకోవాలనే దానికి we use a scale up. Now in between these two, that is first solution what you gave is replacing the original disk with the new disk, with a new disk. And second approach you gave, second solution you gave is we can have some external hard disk. So in between these two, which would be the better choice? Using the external hard disk, this will be the better choice. So we need not to replace it. We need not to copy the data one no, one disk to another disk. Nothing is required. Simply we are going to just add it. Okay. Now I say one approach is called as can I say that this is called a scale up?
Yeah.
Can I call this also a scale up?
Right.
Yes, we are trying to increase the storage capacity in both the approach with both approaches. Now, one is I call one of the approaches as horizontal scaling, and another is called as vertical scaling. Horizontal scaling and vertical scaling. Which is vertical, which is horizontal? Guess, make a guess.
Mhm. Mm, hor- Horizontal is replacing with a new disk,
Uh,
and vertical is scaling external hard disk.
think once again. I write like this. This is, let us say this is the storage, some area. So
Hmm.
if we're trying to increase the area to this by replacing this, okay, new one. This is
Okay.
new area. Instead of this is the first approach
Yes.
that we talked about. Second approach will be like this: one attached with another one.
Okay.
So which is horizontal, which is vertical?
Uh, Horizontal is extended hard disk.
Exactly. This would be horizontal. This is horizontal, and this is vertical. This is vertical scaling. This is horizontal scaling. Okay. So Hadoop uses horizontal scaling of nodes to maintain the data. Okay, horizontal scaling of nodes. Got it? Horizontal scaling of nodes. Let's say here we have four machines. Let us say the capacity of this machine is 1 TB. Let's assume 1 TB, 1 TB, 1 TB, and 1 TB. So totally, what is the total amount of data that can be accommodated into these four machines? Total 4 TB. Okay, 4 TB. Suppose if I want to, I have some extra data 500 GB now. What should I do now? How Hadoop is going to provide a solution to accommodate another 500 GB of data with already existing 4 nodes? What it has to do? Use this horizontal scaling.
Horizontal. Okay.
Then what is the solution? What it has to do? So here we have 4 nodes. So it can add, we can add, it allows us to add one more node. Okay, whenever we want, whenever we require some extra node, Hadoop allows to add any node at any point of time. So this is called as horizontal scaling of data. Got it?
Okay.
ఓకే. అంటే ఎప్పుడు అవసరం
Yeah.
అనుకో డేటా ఎక్కువ అవుతుంది, అవసరం ఇంకొక నోడ్ కావాలి అనుకున్నప్పుడు వి కెన్ యాడ్ ఇట్ ఎట్ ఎనీ టైమ్. వి నీడ్ నాట్ టు యూనో అంతా ఇది మొత్తం ఉన్న డేటా అంతా క్లస్టర్ అంతా ఆపేసి చేసినక్కర్లేదు. Cluster will be
Hmm.
running at the same time. What we can do is we can add a machine and we can include that node also part of the cluster. We can make it part of the cluster. That can be done without making the cluster down. Cluster ni em touch cheyakunda without affecting anything in the cluster. Hadoop allows us to add a new node to the existing set of nodes. Okay, this is called as
Yeah.
horizontal scaling. And let us say we no longer required 2 nodes. We no longer required. Why? Because now we, let us say there may be a case where we may require only 3 nodes for our data. In that case, what has to do, what can be done? We can remove, we can delete these 2 extra nodes from the cluster at any point of time without making any changes, without reflecting anything in the existing nodes or existing cluster. Okay, so any extra node can be added at any point of time, or existing nodes can be deleted from the cluster any point of time without making any changes to the cluster, without affecting data already stored in the cluster. Okay,
Yeah.
this is the reason it is called as highly reliable or flexible. We call highly reliable or highly flexible. Okay, we'll not do anything, just we can add, we can delete, we can do whatever we want without affecting the data present in the cluster. Got it?
Yeah.
So these are the
Yeah.
right. So horizontal scaling. So horizontal scaling is nothing but how many nodes we expect, one or multiple nodes?
Multiple nodes.
Multiple nodes. Okay, high reliability or high flexibility, that is there. Okay, now any amount already we have discussed. So any amount, that is volume, any volume of data, any variety of data, and any what are the speed and with accuracy, that is called as velocity. ఓకే, ఈ 4 ఫీచర్స్ ఉన్న డేటాని జనరల్ దట్ దే కాల్ యాజ్ బిగ్ డేటా. ఓకే, బిగ్ డేటా అంటే బిగ్ డేటా ఇస్ డిఫైన్డ్ బై దీస్ 4 క్యారెక్టరిస్టిక్స్: వాల్యూమ్, వెరైటీ, వెలాసిటీ అండ్ వెరాసిటీ. ఫైన్.
Yeah.
I'll now so nodes, so we are going to have multiple nodes now. Hadoop is a software. Do you agree with this?
Yeah.
Yeah, any product where we call it as a framework or app application or whatever, maybe it is a software, simply a software. Okay, now, so let's assume we have taken 5 nodes. What should be there in these nodes to install Hadoop? What is required? What is required to install Hadoop? What is required? So if you want to install some app, in mobile phones, we use apps, right? We use many apps. Okay, uh,
Right.
mm, we have Android apps, we have iPhone apps, and we have BlackBerry apps, we have Windows apps. Can you tell what is the difference between Android apps and iPhone apps? Is there any difference between them?
A software difference.
What software? Which software is different?
Windows is different. Android is different.
Exactly. So what are the Windows and iPhone, iOS or all Android? What are they called as? They're softwares only, but under
Hmm.
what type of software it is called as? We call them as operating systems, right?
Right.
We call them as operating systems. The mobile operating system, Android is a mobile operating system. Windows is mobile operating system as well as desktop operating system also. Mobile as well as
Yeah.
iOS is also mobile operating system as well as desktop operating system. Itla unnai. So something called as desktop. Without having an operating system, can we install any app or any software in mobile or in Windows in a laptop or desktop? Is it possible?
No.
No, not possible. Exactly. Even if you want to install Hadoop also, what is required is one operating system is required. So requirements. What are the things that are required is the very first thing is we require an operating system. Operating system. So which operating system is required? Which operating system?
Java.
No, Java is a language. Java is a language. I'm asking
Hmm.
operating system. Windows. ఇప్పుడు డెస్క్టాప్ ఉన్నాయి కదా మనకి వీ హ్యావ్ డెస్క్టాప్స్లో we can install
అవును.
Windows, we can install CentOS, we can install Ubuntu, we can install Macintosh. So అట్లా different
Yeah.
operating systems are there. Which one we use? So it
CentOS.
supports, okay, Hadoop supports Windows. Hadoop can be installed on Windows operating systems, Linux operating system. Linux in the sense CentOS, Red Hat Linux, Fedora,
Yeah.
Ubuntu, all these are Linux flavors. And it also
Hmm.
supports Macintosh operating system also, Mac OS. Okay, so if we have five
Yeah.
nodes, these five nodes should have either Linux or Windows or Macintosh. So try to see that if a node has Linux, try to have the same operating system in all the nodes. Do not try to have heterogeneous ఇక్కడ Linux పెట్టి ఇక్కడ Windows పెట్టి ఇక్కడ iOS పెట్టకండి. So try to have same operating system, same version and same operating system in all the nodes. The very first thing required is operating system. Fine. Now second thing is, hello, Rajesh ఉన్నారా? హలో.
Yeah.
యా.
మీ వాయిస్ బ్రేక్ అవుతుందండి మధ్యలో.
ఈ ఎవరో మధ్యలో పవర్ పోయి వచ్చింది, అందుకే మర్చిపోయింది అట్లాగా.
ఓకే 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 ఓకే.
సో ఒక ఆపరేటింగ్ సిస్టమ్ కావాలి. అండ్ వాట్ ఎల్స్ ఇస్ రిక్వైర్డ్ ఈస్ వాట్ ఈస్ ద లాంగ్వేజ్ యూజ్డ్ ఫర్ డెవలపింగ్ దిస్ Hadoop?
జావా.
Java. Okay, so we require Java also to be installed in the operating system. Java also to be installed. Be installed. హలో, ఉన్నారా రాజేష్?
యా
యా.
యా యా అంతే
ఎవరో లెఫ్ట్ అని వచ్చింది, అందుకే మళ్ళీ చూసాను. హమ్ కాలర్.
అంతే.
Okay, so operating system and Java has to be installed. So we can take, so preferred is Linux. అంటే ఇప్పుడు ప్రిఫర్డ్ ఇస్ వై బికాస్ ఇన్ ఇండస్ట్రీ ప్రొడక్షన్లో ఎక్కువ యూజ్ చేసేది లినక్స్ ఆపరేటింగ్ సిస్టమ్ బికాస్ హైలీ సెక్యూర్డ్. సో ప్రిఫర్డ్ ఇస్ లినక్స్. It doesn't mean that only Linux, it can support Windows or it can support even Windows is providing a better solution, good solution for this Hadoop also. Okay, Linux and Java must be installed, or Java must be installed in all these file systems, in all these nodes.
యా.
Right now Linux is there, Java is there now. So when we install Linux, do we get any file system in that? Any file system with that? ఇప్పుడు విండోస్లో మనము డేటా స్టోర్ చేస్తున్నాం కదా, వీఆర్ స్టోరింగ్ ఫైల్స్ అండ్ డైరెక్టరీస్, రైట్? What who is storing that? Actually some process will be there inside internally that will store, maintain the data actually. ఇప్పుడు డేటా
రైట్
అవుతుంది, the data will be returned to the disk, right? Okay,
రైట్.
there must be someone to to move the data, which acts as the interface between the disk and user, మనకు డేటా చూపించడానికి. We cannot understand disk storage. Why? Because the disk will store the data in bits, totally bits లాగా రైట్ చేస్తుంది. We don't understand it. There must be some interface between the who can understand the bit storage and who can convert that bit storage into our understandable format. మళ్ళీ మనం సేవ్ చేసినప్పుడు that must be stored as bit format. Who is going to do that? and who is going to maintain information of all the files, all the directories that we have in our laptop or desktop. Whether we install Linux or whether we install Windows or Macintosh, we can have directories, files, so audio files, video files, అన్నీ ఉంటాయి కదా. So who is going to maintain the information of all these files stored in our machine? So that is called as a file system. That is called as a file system. Now coming to Windows. What is the file system used by Windows? What is the file system? File system, that is operating system and corresponding files. What is the file system? Have you heard about FAT anytime? And HDFS? ఇప్పుడు మీరు ఒక పెన్ డ్రైవ్ అని ఏదైనా పెట్టారనుకోండి, విండోస్ మీ దగ్గర విండోస్ ఉంది కదా, ఒక పెన్ డ్రైవ్ అని పెట్టి దాన్ని ఫార్మాట్ చేయండి. రైట్ క్లిక్ కొట్టి ఫార్మాట్ అని అంటారు కదా, ఎఫ్ఎఫ్ పెట్టినప్పుడు అక్కడ ఒక ఆప్షన్ వస్తుంది. వాట్ డు వి గెట్ అట్ యాస్, లెట్ మీ షో యూ సంథింగ్. Now PC, open this, and I'm right click on this directory. Can you see format here? Okay,
Yes.
I'm clicking on this format simply. So can you see something here, NTFS ikkada from the file system అని కనిపిస్తుంది, file system NTFS ఉంటుంది. And we have one more file system that is called as FAT. FAT is the old file system Windows use చేసేది, NTFS is the latest one. So every operating system uses a file system to maintain the data in the machine. What it understand like this?
Yeah.
So here, as we have been discussing that, so Windows uses NTFS file system or FATS file system. It can use anywhere. Similarly, Linux operating system. What file system is used by Linux? లినక్స్ వాడరు కదా మీరు, సెంటోయిస్ మీరు వాడుతున్నారు కదా, అప్పుడు స్పార్క్ అప్పుడు వాడారు అనుకుంటాను. ఎస్, ఓకే. అక్కడ మనకు సి డ్రైవ్, డి డ్రైవ్ అన్ని ఉంటాయా? ఉండవు. ఇట్స్ అక్కడ కూడా ఫైల్ సిస్టమ్ ఉంటుంది, బట్ ఇట్స్ స్టోరేజ్ అండ్ హైరార్కీ రిప్రజెంటేషన్ విల్ బి టోటల్ డిఫరెంట్ దట్ ఆఫ్ విండోస్ ఫైల్ సిస్టమ్. అక్కడ సి డ్రైవ్, డి డ్రైవ్, ఈ డ్రైవ్స్ అవన్నీ ఉండవు. ఇట్ విల్ బి సమ్వాట్ డిఫరెంట్. But even it is a file system, it is also a file system. That file system is called as extendable file system or ext3 antar. ext4 is the latest version. Extendable file system version 3, extendable file system version 4. These are the file systems of Linux operating system. Okay. So when we install in the machines, in the 5 machines, let us say we are trying to install Hadoop in these machines, and we have connected all these in a network, and let us try to have Linux operating system in all the machines, in all the nodes. And what is the file system that is present here? Let us talk about ext4, something like this. Okay, now I ask a question to you now. Suppose if we have 2 desktops or 2 laptops, paka pakana better anukondi, okay, and they are connected in a network. They are connected in a network also. So network under what is the meaning that they are connected in a network? What happens with that?
The data can be mutually transferred.
Exactly. That means data communication is possible, isn't it? That is, the machines can communicate. How do they communicate? Through exchange of data. అక్కడ నుంచి ఇక్కడ పంపించుకొని చేస్తుంది. So that is called as a network. If they are network, they know they can exchange the data. That's fine, right? Now, one more question. If we store some file into one node, అంటే one node machine లోకి ఒక ఫైల్ కాపీ చేసాం, okay, so does that file gets copied to other machine also? I'm asking that if you are copying one file into one machine, whether that file gets copied into another machine also? మనం చేయం. We copy into only one machine. We copy a file into only one machine. does that file gets stored into another machine automatically? అవుతుందా
No.
అవదా? No, that won't happen, right? That won't happen. Okay.
Yes.
And suppose ఒక మనం ఏం చేసామంటే ఒక నోడ్ ఉంది. We have, let us assume the case like this. We have two nodes like this. Let us say Linux or Linux. It can be anything. Now, if we store some file into, let us say 5G, okay, 5 GB అనుకుందాం. 5 GB data we have loaded into this one. So 5 GB will not be loaded into this node unless we copy or మనము ఇక్కడికి మూవ్ చేయాలని మనం అనుకుంటే తప్ప మూవ్ అవ్వదు. It will be created only once. Okay, it will be created only once. Now, suppose one more question, that is automatic data copying is not possible. Do you agree with this? Automatic
Right.
data copying is not possible. Is not possible. Second one, that is 5 GB I have loaded into this machine. Is 2.5 GB into this machine, another 2.5 GB into this machine. Does it happen automatically? Can we do this? Can we divide the
No.
data into, can we divide the 5 GB into two parts and can we store into two machines? Is it possible or not?
Yes.
Yes, that is possible. That we have to do manually. Anta kadavadu, that won't be done automatically. We have to divide the data into two parts and we have to copy some data, first part into one machine, another part into another machine. That we have to do manually. So that is automatic division of data. Automatic division of data is also not possible. So what is a file system that is used in Linux? Extendable file system. Extendable file system. Okay. Now, can we call this data as, so how many file systems are running here in these two nodes? How many file systems are
Two.
running? Two. Okay, one file system is in the first node and another file system is in the another node. So as they are different, దానికి సంబంధం లేదు, దాంది దాందే, దీంది దీందే. సో ఆటోమేటిక్ రెప్లికేషన్ కానీ ఆటోమేటిక్ డివిజన్ ఆఫ్ డేటా అనేది that is not going to happen. Okay, remember these 2 points. If you understand these 2 points, it's very easy, very easy to understand HDFS. Okay, see this now. In the 5 nodes we have ext4. Just let me draw like this, ext4. Let me call this as disk. దీని డిస్క్ అనుకుంటాను, ఈ పోర్షన్ని నేను డిస్క్ అని లాగా అనుకుందాం. మెమొరీ కాదు, డిస్క్ అనుకుందాం. సో ద డేటా విల్ బి స్టోర్డ్ ఇంటూ డిస్క్. ఇంతే కదా, డేటా డిస్క్లో ఉంటుంది. సో who will maintain the information of the data present in the disk? Will maintain that.
Mm.
File
File
system.
system.
File system. So file system will maintain that. ext. Let me use ext file system here and ext. Okay, ext file systems. Now, so ఇట్లా network లో all these are connected in network. Still, even though they are connected in a network, they cannot automatic data copying, automatic division is not going to happen. Okay, now I have 5 TB of data. ఇప్పుడు నా చేతిలో 5 TB of data ఉంది. Okay, and I have 5 machines where the capacity of each machine is 1 TB, 1 TB, 1 TB. That is hard disk size. Is it possible to accommodate this 5 TB of data into these 5 machines? Is it possible? ఒక 5 nodes ఇచ్చాము మీకు అండ్ ద కెపాసిటీ, కెపాసిటీ 5 nodes కెపాసిటీ కాకపోతే 5 TB అవుతుంది. కెన్ వి లోడ్ దట్ 5 TB ఆఫ్ డేటా ఇంటూ దీస్ మెషిన్స్ ఆర్ నాట్? చేయొచ్చా మాన్యువల్గా అయినా? హలో హలో రాజేష్ ఉన్నారా? హలో ఆర్ యూ ఏబుల్ టు హియర్ మీ రాజేష్? Hello. Hello.
Hello?
Yeah, Rajesh. Is there any problem?
Hello?
Yeah, yeah.
Sorry అండి పవర్ పోయింది.
Oh, no. Okay, no problem.
Oh,
Right.
no.
Right. So coming to the question here, we have 5 nodes.
Mm.
If we combine the capacities of all the 5 nodes, it would become 5 TB. Now I have a file, some data of size 5 TB. So is it possible to load this 5 TB of data into these 5 machines
Yeah.
or not? Is it possible or not?
Yes.
Yes. So for that, what we need to do? First,
Yeah,
we
it's
have to,
possible.
yes, manam cheyali actually. Automatic division will not happen. We have to divide the data 5 TB into 5 pieces. So each piece of size 1 TB, and we have to copy into these 5 machines separately, one into these machines. Okay. Okay. Let us say we have only 5. What if we have some 50 TB of data? Can we do it manually? Okay, let us say, oh, 4 to 5 people are there. We have recruited 4 to 5 people. They are doing that work. Let's say, and let us say, 1,000 TB of data. Is it possible to load the divide the data manually? No, that is not
No.
correct. That is the correct approach, Kadadi. So we cannot do everything manually. Why? Because there may be no not only text to files. అన్ని text files ఉండవు కదా. There may be some images, videos, audios చాలా ఉంటాయి. అవన్నీ మనం మాన్యువల్గా డివైడ్ చేయాలి
Yes.
డేటా అంటే దట్ ఇస్ నాట్ గోయింగ్ టు బి పాసిబుల్ యాక్చువల్లీ. బట్ ఒకటి ఏదైనా ఒకటి ఉంటే బాగుండేది ఏంటి అంటే ఇట్ మస్ట్ ఆటోమేటికల్లీ డివైడ్ ద డేటా ఇంటూ పీసెస్ వాట్ ఎవర్ ద పీస్ నెంబర్ ఆఫ్ పీసెస్ వీ వాంట్ చేస్తే బాగుంటుంది కదా. ఓకే, సో ఇక్కడ 5 nodes ఉన్నాయి. ఇఫ్ యూ కంబైన్ ద కెపాసిటీ
Yeah.
ఆఫ్ ద ఫైల్ ఇట్ వుడ్ బికమ్ 5 TB. We have everything is there, but if there is someone to automatically divide the data into 5 nodes up automatically, మన imitation కాకుండా just we have to say that divide this data into 5 parts మనం చెప్పామనుకోండి. Is there anyone to do like that? Yes. So మనకి ఒక సొల్యూషన్ కావాలి ఏంటి అంటే దట్ సొల్యూషన్ హ్యాస్ టు గివ్ అస్ ద ఫ్లెక్సిబిలిటీ ఆఫ్ ఆటోమేటిక్ కాపీయింగ్ ఒకటి అండ్ ఆటోమేటిక్ డివిజన్ డేటా. ఆటోమేటిక్ డివిజన్ ఈ రెండు జరిగిపోవాలి. సో సమ్వన్ ఒకటి ఉంటే బాగుంటుంది. డివైడ్ చేసేవాళ్ళు ఆటోమేటిక్గా డేటా కాపీ చేసే వాళ్ళు కూడా ఎవరైనా ఉంటే బాగుంటుంది మనకు. సో సచ్ వన్ సచ్ సొల్యూషన్ వన్ సచ్ ఎంటిటీ అనుకోవచ్చు, కాంపౌండ్ ఏమని అనుకోవచ్చు, దట్ ఈస్ HDFS. ఓకే, one is HDFS.
Yeah.
That's it. So HDFS can divide the data automatically and it can copy the data from one node to another node. Everything that will take care of. That's it. మనం జస్ట్ లోడ్ అని ఒకసారి లోడ్ చేయడం మనం చేసే చాలు. మనకి కావాల్సినట్టుగా ఇట్ విల్ డూ ఆన్ ఇట్స్ ఓన్ వాట్ ఎవర్ మే బి ద అమౌంట్ ఆఫ్ డేటా, వాట్ ఎవర్ మే బి ద వెరైటీ ఆఫ్ డేటా, అండ్ వాట్ ఎవర్ మే బి ద స్పీడ్ ఆఫ్ జనరేషన్ అవుతాయి ఎంత అన్న కానివ్వండి. It can do automatically division, it can do automatically copying of data into any number of nodes that are there in the network. Got it? That is nothing but HDFS, Hadoop distributed file system. That's it, motherfucker. Okay, now so what I do is now I install Hadoop in all these nodes. So this HDFS is going to come on top of it. ఇప్పుడు ఈ క్వశ్చన్ కరెక్ట్ గా ఆన్సర్ చేయండి రాజేష్. ఒక డిస్టర్బెన్స్ వస్తుంది రాజేష్ మీ సైడ్ ఒకసారి.
Hmm.
ఒక డిస్టర్బెన్స్ ఎక్కువ వస్తుంది.
నేను బయటకు వచ్చేది సిగ్నల్ నేను మ్యూట్ లో పెడతానండి.
ఓకే ఓకే ఓకే, జస్ట్ ఆన్సర్ మై క్వశ్చన్. దాని డిస్టర్బెన్స్ ఉండనివ్వండి, బట్ ట్రైన్ టు ఆన్సర్ దిస్ క్వశ్చన్. నౌ ఐ సే దట్ there must be something to do automatic revision and automatic copying of data. So I gave that that one is HDFS. Now we have 5 nodes here. Okay, Okay, if I nodes low,
Mhm.
how many instances of ext file system is there? How many instances or how many copies? ext external file system ఎన్ని ఉన్నాయి? 5 ఉన్నాయి.
Come again, sir.
How many?
5 ఉన్నాయి.
5 ఉన్నాయి కదా. Now I am asking
Mm.
a question. Try to answer this carefully. Okay, how many
Mhm.
instances of HDFS has to be there in all these 5 machines so that it can do automatic division, automatic copying? How many instances of HDFS has to run on all these machines?
5.
5.
Yeah.
Think once again.
No, no, no. One is enough. One is enough.
Why? Why only one?
The HDFS that will distribute data into these extensions.
Yes, exactly. Wow, whatever be the number of nodes, any nodes are not. Okay, only one
Mm.
instance of HDFS will be created in all the nodes. That's it. Very simple. Okay, so but internal the
Yeah.
operating system file system will be individual for every node, but HDFS will be only one copy. Only one copy HDFS will be maintained. That's it. Very simple. Okay, so only one
Yeah.
copy of HDFS will be maintained in all the nodes. That's it. Very, very simple. Got it right? Now you got the rough idea of what is HDFS.
Yeah.
HDFS is a
Yes.
file
Yes.
system which can automatically copy the data as well as automatically divide the data into the machines. That's it. Very simple. And what flavors of machines? It can be Linux flavor, it can be Windows, or it can be Macintosh. It can be anything. It can do that. That's it. Very simple.
Yeah.
Now, into this HDFS. 1, 2, 3, 4, 5. Let me take 5 nodes again. So only one copy of HDFS will be available in all the nodes. Now, what is the architecture of this HDFS? Already we have discussed in the previous slide. That is, it is master-slave architecture.
Master slave.
Slave architecture. Okay. So can we call this as
Yeah.
1, 2, 3, 4, 5? ఇప్పుడు ఎట్లా అంటే ఒక ఒక 10 మంది ఉన్నారు. ఓకే, 10 పీపుల్ ఆర్ దేర్. ఎవరితో ఎవరికి సంబంధం లేదు.
Mm-hmm.
అప్పుడు ఏం చేయాలి? యునో ఎవ్రీ వన్ హ్యాస్ దేర్ ఓన్ వాట్ కాల్ యాజ్ ఇంట్రెస్ట్ ఆఫ్ డూయింగ్ ద థింగ్స్. యాక్చువల్లీ అట్లా కాకుండా 10 పీపుల్ ఆర్ వర్కింగ్ యాజ్ అ టీమ్. 10 people are working as a team. That means the distribution of work and అదంతా అందరూ కలిసి చేసుకుంటూ ఉన్నారు. So they are communicating properly and they are doing the work. Okay, now 10 people are working
Yeah.
as a group, as a team. Okay, now there must be someone to handle all these 10 people. Then only that the work will go on smoothly. There must be someone to handle these 10 people, so that their communication, whether all the people are doing the work properly, whether they are communicating properly or not, someone has to monitor this and someone has to maintain all these 10 people. Who is that? మనకి ఇప్పుడు కంపెనీస్లో అట్లాగే ఉంటుంది కదా, టీమ్ మెంబర్స్ ఉంటారు అండ్ టీమ్
Mm-hmm.
టీమ్ లీడ్స్ ఉంటారు,
Yes.
వాళ్ళ పైన ఉంటారు. సో ద టీమ్ లీడర్ హ్యాస్ టు సీ దట్ ఆల్ ద టీమ్ మెంబర్స్ అందరికీ వర్క్ డిస్ట్రిబ్యూట్ అయిందా లేదా, ఆర్ దే డూయింగ్ ద వర్క్ కరెక్ట్లీ ఆర్ నాట్, అండ్ గెటింగ్ ద స్టేటస్ ఆఫ్ ది వర్క్. సో ఇదంతా ఎవరు మెయింటైన్ చేయాలి? టీమ్ లీడర్ హ్యాస్ టు మెయింటైన్. ఓకే, నౌ ఇక్కడ చూడండి, we have
Team leader.
yes, team member 1, team member 2, team 3, team member 4 and team member 5 and team leader, let us say. So ఒక వర్క్ వచ్చింది, work 1 has come. Now team, what the team leader will do? Team leader will divide that work 1 among 5 people. అందరికి డివైడ్ చేస్తాడు. సో కొంచెం పార్ట్ W1
Yes.
5, ఫిఫ్త్ పార్ట్ అందరికీ డిస్ట్రిబ్యూట్ అయిపోతుంది. Okay, and at the same time,
Mm.
whether this team member is doing the doing the task or not, ఆ వర్క్ చేస్తున్నాడా లేదా అనేది ఎవరు మానిటర్ చేయాలి? Who has to monitor that? Team leader has to monitor that.
Team leader.
Team leader. And what is the work assigned to them and what is that I am expecting, everything that should be maintained by the team leader. Okay, how many works
Team
are there
leader.
here? ఎన్ని వర్క్స్ ఉన్నాయి ఇక్కడ?
5.
Works ikkada.
One work.
It's
One work.
actually only one word that has been
One work.
divided into 5 parts. Okay, exactly. Can we call this as master and slave? Ante slave and అనడానికి లేదు team members ni, but I'm saying like that. So can I call this person as master, and can I call this persons as workers? Something like
Yeah.
that. Worker ani I don't not trying to exploit the people, just రాస్తున్నాను అంతే. Okay, master and workers. Exactly the same architecture or scenario will be used by the HDFS. That's it, very simple. That is called as master slave architecture. That master process is called as name node. Is called as name node. That master is called as name node. And these slaves, these team members will be called as what? They are called as data nodes. Data node and data node, data node and data node. That's it, very simple. Okay, so వీరంతా కలిపి
Yeah.
only one team. Only one team. That's nothing but only one instance of HDFS. Got it now? Okay, HDFS.
Yeah.
One instance of HDFS will contain one master and how many slaves? How many slaves?
Number of.
Multiples. We can say simply multiple. It can be 2 or 3 or 4, depends, depending upon the requirement. There can be multiple slaves. That's it, very simple. So this called as master slave architecture. What is the master process name called as name node, and slave process
Name node.
called as data nodes.
Data node.
That's it, very simple. ఇంత మించి ఏముండదు, పెద్దగా ఏముండదు. కాన్సెప్ట్ వైజ్ తీసుకుంటే గింత
Okay.
ఉంటుంది. ఓకే, నేమ్ నోడ్ అండ్ డేటా నోడ్స్ అంతే. సో ఏదైనా వర్క్ వచ్చింది అంటే దట్ విల్ బి డిస్ట్రిబ్యూటెడ్ టు ఆల్ ద వర్కర్స్ అండ్ దట్ విల్ బి డన్. సో ఇక్కడ ఏం చేద్దామంటే దీంట్లో I say I install name node here, I install data nodes in all the 4 machines. For the machines. Now this node will be called as master node.
Master.
Why I'm calling it as master node is master process is running in that node. And these nodes are called as slave nodes. Why? Because slave process are running in these nodes. That's it. Okay, now if the size of if the size of each node is 1 TB, let us say now 1 TB, 1 TB, 1 TB and 1 TB. Now we have the data of size, some 3 TB data is there. 3 TB data is there. Let us take 2 TB of data. 2 TB of data is there. How to now I will try to load the data into this HDFS. To whom I will give the request now? Everyone request cheyali? Master
Name node.
Name node, exactly. Okay, we need to request master that I am trying to load 2 TB of data into you. So that name node will try to divide it into how many parts? How many parts?
2 parts.
2 TB is there. 1 TB, 1 TB. It need not be exactly 2 parts.
Yes.
If you want, we can decide like this. ఎట్లా చెప్పొచ్చు అంటే ఏం చెప్తామంటే try to have the size of each part to be 1 TB అన్నాం అనుకోండి. The size of each part, each division to be 1 TB అంటే ఎన్ని parts అవుతుంది? 2 parts అవుతుంది. So only 2 data nodes are going to get the data. Remaining data nodes are not going to get any data. They will be idle. సో అట్లా కాకుండా ఏం చేస్తామంటే యూనిఫామ్ గా డిస్ట్రిబ్యూట్ చేయాలి డేటా, అందరికి వర్క్ వచ్చేటట్టుగా. అప్పుడు ఏమవుతుంది? సో ఇన్స్టెడ్ ఆఫ్ సేయింగ్ 1 TB, వాట్ డూ సే? హాఫ్ TB. 0.5 TB పెట్టామనుకోండి, అప్పుడు 0.5 ఇక్కడ, 0.5 అండ్ హాఫ్ TB అండ్ 1 more half TB టు దిస్ నోట్స్. ఈ హాఫ్ TB అనేది మనం చెప్పాలి, ఎంతసేపు మనం చెప్పాలి. చెప్తే దట్ విల్ బి ఆటోమేటికల్లీ డివైడెడ్ బై HDFS into 4 parts automatically. We need not to worry about that. That's it. Got it? That is called as HDFS. Automatic data division will be done by HDFS. Clear?
ఈ డేటా నోడ్ సైజ్ మనం ఫ్రీక్వెంట్ చేంజ్ చేసుకోవచ్చు అండి.
డేటా నోడ్ అంటే
డిపెండ్ అపాన్
ఒక్క నిమిషం, అది కాదు. ఇప్పుడు డేటా నోడ్ సైజ్ ఎంత ఉంది? టోటల్లీ 1 TB కదా. 1 TB. So how much data we are loading now? Half TB. ఇంకా ఎంత స్టిల్ హాఫ్ TB ఆఫ్ డేట్ సైజ్ విల్ బి ఫ్రీ. ఇంకా హాఫ్ టీబీ స్పేస్ ఫ్రీగా ఉంటుంది. If we have one more 2 TB of data undanukondi, still we can load one more 2 TB of data also into 4 nodes uniformly. That is possible.
Understood.
Okay, so oka file kaadu, we can load the data any number of files into HDFS as long as the capacity supports. దాంట్లో స్పేస్ ఉన్నంత వరకు ఎంతనా లోడ్ చేసేసుకోవచ్చు. It need not be only one file.
Okay.
Got it? అది ఎంత అవసరమో అంత తీసుకుంటుంది, మిగతా స్పేస్ అంతా ఫ్రీగానే ఉంటుంది. దట్ కెన్ బి యూజ్డ్ ఫర్ అనదర్స్ డేటా. దట్ కెన్ బి డన్.
Yeah.
అర్థమైంది కదా? వెరీ సింపుల్. వెరీ
Yeah. Clear.
And so we have been talking about HDFS and yarn here. So in HDFS, the master process we are calling it as what? Name node. And this process, slave process, we are calling it as data node.
Data.
So HDFS is confined for only storage. Only for storage. So what is being used? Disk is used for storage purpose, isn't it? Because store avutundi data anta, that data will be stored into the disk.
Yes.
Now, if you want to process the data, then what? How?
Yarn.
Okay. So which will be which space will be used? Disk space or memory space? Primary memory. ఏది యూజ్ అవుతుంది ఇప్పుడు? ఇప్పుడు మన డిస్క్ లో డేటా ఉంది, ఇప్పుడు మన సిస్టమ్ డిస్క్ లో డేటా ఉంది, దాన్ని ఆ డేటాని మనం ప్రాసెస్ చేయాలి అంటే ద డేటా హ్యాస్ టు బి లోడెడ్ ఇన్ టు వేర్? ఫ్రమ్ డిస్క్ టు RAM. Exactly. Okay, the data must be loaded from disk to RAM. And ఆ RAM లో ప్రాసెసింగ్ జరగాలి కదా, ఆ RAM లో ప్రాసెసింగ్ జరగాలి.
Yes.
So I give very simple scenario. 1 2 3 4 5. Now this is the name node running in this node, and data node, data node, data node, and data node. Totally 5 data nodes. So let's say we have loaded some 2 TB of data into this HDFS. So every node is going to get half TB, half TB, half TB of data. This is fine. It is the data is stored into the disk. Now, if you want to process the data, then what has to be done? This half TB of data must be loaded from disk to memory. Let me call this as memory. ఈ part memory అనుకుందాం. So this half TB of data must be loaded from disk to memory. Disk to ఇక్కడికి రావాలి, మెమరీకి వచ్చి ఇక్కడ ప్రాసెసింగ్ జరగాలి. Processing must be done here. Who is going to do that processing? Who is going to do that processing? ఓకే, అగైన్ దేర్ ఈస్ వన్ మోర్ ప్రాసెస్. ఒక ప్రాసెస్ ఉంటుంది అక్కడ, ఒక సర్వీస్ ఉంటుంది లైక్ డేటా నోడ్. డేటా నోడ్, వాట్ ఈస్ ద డేటా నోడ్? డేటా నోడ్ ఈస్ అ ప్రాసెస్ which will maintain the information of the data present in the disk in HDFS. That is the data node. And there must be someone to process this data. ఈ మెమరీలోకి వచ్చిన తర్వాత దీన్ని ప్రాసెస్ చేయాలి డేటాని. So who is going to involve in the processing of the data? Okay, there comes the services of yarn. అప్పుడు యాన్ కామి బయటకు వచ్చేస్తాయి. ఓకే, సో డేటా నోడ్ ఇక్కడ వచ్చేసి వి కాల్ ఇట్ యాజ్ ఎన్ఎం. ఎన్ఎం is called as node manager. That is node manager. And one more is called as resource manager. RM and node manager, node manager, node manager, and node manager. Can you say now? So this resource manager is acting as a master process of what? Master process of yarn. And node managers are acting as the slave process of what? Yarn. Got? So resource manager and node managers, they are going to involve in the processing of data, and name node and date nodes are going to involving in the storage of data. That is the difference between them. Okay, yarn for storage. So during the processing, RAM will be used, and during the storage, disk will be used. That's really simple. So let me finalize these two, HDFS and yarn. Let me write like this. So HDFS for storage and yarn for processing. And what is the master process called as? Master name node. And what is the slave process called as? HDFS data node. Let me write full names here. Sorry, name node, and this would be data node. Data node. Let me call as slaves. ఎందుకంటే మల్టిపుల్స్ ఉంటాయి కాబట్టి let me call them as slaves. And here the master. What is the name of this master? This is resource manager.
Resource manager.
Resource manager, RM. And the slaves will be node managers. Node managers, NM. That's it, very simple. So even this follows master slave architecture, and yarn also follows, is also master slave architecture. That's it, very simple. And how many copies of HDFS will be maintained? Only one instance. One instance of HDFS and one instance of yarn in one Hadoop cluster. ఒక Hadoop cluster లో in one Hadoop cluster we'll have one instance of HDFS, one instance of yarn. That's it. This is simply Terrace's coach. Okay. Any questions in this?
Clear,
right? Okay. Shall we stop for today?
Yeah.
Fine.
అది ఒకసారి మీరు ఫ్రీగా ఉన్న టైంలో ఇన్స్టాలేషన్స్ అవి చెప్పరా?
ఇప్పుడు ఫ్రీ ఉన్నారా? Shall we see that?
పవర్ లేదు.
పవర్ లేదా? ఫ్రీ ఉంటారా మీరు ఈ 2 తర్వాత?
ఫ్రీగా ఉంటాను.
అయితే
ఫ్రీగానే ఉంటాను సార్.
ఉంటారా? నేను ఇప్పుడు లంచ్ తీసుకొని ఒక 3 o'clock తర్వాత మీరు చెప్పండి. ఆర్ ఈవినింగ్ ఏమైనా ఛాన్స్ ఉందా? ఈవినింగ్
ఎన్నింటికంటే ఈవినింగ్
చాలా లేట్ అయిపోతుంది నాకు కూడా. 8-9 అవుద్ది.
8-9 ఈరోజు పర్లేదండి.
అవునా? అయితే ఓకే, ఈవినింగ్ చూద్దాం. ఎందుకంటే నేను వేరే పని ఉంది, ఇప్పుడు వెళ్తాను అక్కడికి. సో ఏవే ఉన్నాయో అన్ని దగ్గర పెట్టేసుకోండి, నెట్ కనెక్షన్ పెట్టుకొని అన్ని పెట్టండి. విల్ సీ. విత్ ఇన్ one shot everything will be done. Okay, fine.
ఓకే, థ్యాంక్ యూ. నాకు డీటెయిల్స్ పంపించారా?
పంపిస్తాను. I will send now.
Right, thank you.